Assalamualaikum. To my examiner, Dr. Siti Nurul Ain. My name is Nur Adlina binti Azhari, and I'm going to present my poster of research project 2 entitled A Review on Hybrid Alginate and Beta-Cyclodextrin aerogel for drug delivery by supercritical drying. The objective of this research is to review the hybrid alginate and beta-cyclodextrin aerogel for drug delivery by supercritical drying, how hybrid alginate aerogel can be prepared, and benefit it can provide as drug carrier. For the problem statement, issues such as controlled release of drugs, lack selectivity to the targeted site, protection of drugs against external and enzymatic degradation, low loading of drugs, and biodegradability always correlated with the drug delivery system. Thus, an alternative method of natural polymer of hybrid alginate aerogel as drug carrier might solve the problem. Natural polysaccharide is known as biomaterial, which give the benefit of biocompatible, easily accessible, stable, biodegradable, susceptible to chemical modification, cost-effective, non-toxicity, and renewable. The modified polysaccharide have been found to be a good replacement to the available synthetic polymer in the pharmaceutical industries. The biochemical characteristics of polysaccharide are quite similar to the extracellular matrices of human cells. Hence, they can be easily acknowledged by our body. Natural polysaccharide can be obtained from sources of animal, plant, algal, and microbial. Alginate and beta-cyclodextrin are amongst the promising natural polysaccharide that have been studied due to their excellent characteristics for drug delivery. Alginate is mainly originated from the algal source, the brown seaweed, and beta-cyclodextrin is a natural molecule derived from the starch. Based on the previous research, a hybrid alginate and beta-cyclodextrin for drug delivery was prepared using freeze drying technique. Ketoprofen was used as the drug model. At higher amount of beta-cyclodextrin, the loading efficiency of ketoprofen was increased. The size of nanoparticle less than 100 nanometer cannot be achieved at higher concentration of beta-cyclodextrin. This indicates beta-cyclodextrin have influence toward the size of aerogel nanoparticle. At slightly alkaline state, the gel can protect ketoprofen from loss to the environment and give function of control release. The structural properties of aerogel was better with supercritical drying compared to other drying techniques. For the overall process to produce hybrid alginate aerogel, it involved the mixing of two or more precursors that undergo hydrolysis to form solution, then undergo dilation to form hydrogel, then undergo solvent exchange by alcohol to form alcohol and undergo supercritical drying to form aerogel. From the previous methodology by other researchers, the preparation of hybrid agenate aerogel comprises of three primary processes, which are the gelation, the aging, the solvent exchange, and the drying process. For the gelation, it can occur through two methods, which are diffusion and internal setting. For the diffusion method, divalent cation are entering the aqueous hybrid agenate by large oxide reservoir. The aqueous hybrid agenate can be dropped slowly into a solution of calcium chloride. In this case, the calcium chloride acts as the large oxide reservoir. The concentration of divalent cation is said to be over the gel thickness. In this method, spherical bits of gel are formed. For the internal setting method, divalent cation are reside inside the hybrid agenate solution. The cross-linking ions are entering the aqueous hybrid agenate, which triggered by the pH of or solubility of ions. In this case, calcium carbonate and gluconodectalactone are used as the cross-linkers. The concentration of ion is said to be uniform throughout the gel. In this method, a monolith shape of gel are formed. For the gelation process, ionic cross-linking agents are very crucial for gelation to occur. The molecular weight and viscosity of agenate will highly impact the formation of gels. As the molecular weight of agenate is higher, the viscosity also will be greater. Hence, it will lead to difficulty for agenate to dissolve in the water. Practically, a maximum amount of 5% to 6% content of sodium agenate is allowable in the agenate solution to prevent high viscosity of the solution. For gelation process to occur, it must consist of suitable precursor, crosslinkers, and solvent. In order to produce a hybrid agenate and beta-cyclodextrin aerogel, the suitable precursors are sodium agenate and beta-cyclodextrin powder. The cross-linkers agent can be used are calcium chloride, calcium carbonate, gluconodectalactone. For the solvent, distilled water is used. Next, move to the solvent exchange process. In the solvent exchange, hydrogel will undergo several washing with different ratio of alcohol to water for a few days, with maximum duration of 24 hours for each concentration. The purpose of solvent exchange is to remove impurities and water from the gelation process. It also to prevent a greater shrinkage of the gels during supercritical drying. At longer period of aging, the shrinkage of gel can be lowered. For the drying process, Supercritical drying is used because it can preserve and shield the network structure of gel from degradation. In supercritical drying, the liquid inside the gel is replaced with gas without destroying its pore structure. It occurs at operating conditions of pressure and temperature exceed the critical limit of solvent. Carbon dioxide is commonly used as solvent since it is safer and inflammable. The alcohol gel can be extracted at low temperature with carbon dioxide compared to solvent with high critical temperature. Thus, the gel would not be decomposed or react at supercritical temperature of solvent. In the future, an excellent system of drug delivery for pharmaceutical industries can be achieved by hybrid alginate aerogel. The engineering of aerogel nanotechnology can solve the physical challenges of the current medicine technology. The high specific surface area, porosity, open pore with stable network of aerogel can be altered to suit the application of drug delivery system. And advanced and specified studies of hybrid alginate nanoparticles should be performed further for the application of drug carrier. In a conclusion, the formulation of natural polymers as drug carrier is ideal compared to synthetic polymers since they are biocompatible, biodegradable, safe, and abundant in nature. Natural polysaccharide aerogel can provide a solution to the problem associated with conventional drug delivery system. Hence, that have ended my poster presentation. Thank you for your time and evaluation.